Alright, hello, welcome back. Today in this video I'm going to be working the problems from BC Review number 6, which is multiple choice no calculator. And I am going to be going in reverse order, so I'm going to be starting with number 18. Alright, so let's get after it. Number 18 is, alright, they're telling us that dx dt is 5 and dy dt is sine of t squared. How are we doing on size here? That's all right. Yeah, you can see that very clearly. Okay, well, then they're going to want you to find the second derivative of y with respect to x both times. And this one was very commonly missed in both of the sections that I have looked at the data for. But that is to be expected, right? This is the second derivative of y with respect to x both times on a parametric curve is one of those things that we just have to remember. There's a special formula for it. What we do is we take the derivative with respect to t of dy dx, which I'm not even seeing yet. I guess we're going to have to figure out what that is. Then we need to remember to divide by dx dt, and honestly, that's why it came at the back end. It's one of the harder multiple choice no calculator questions, not because it's that hard, because it's hard to remember that you're supposed to divide by that dx dt. Everyone always forgets about that, but you do need to. And also, if you're interested on why is that the case, I do have a video on that also. It's basically has to do with the quotient rule. But you can investigate yourself, or you can just search my channel for why do you divide by dx dt. Anyway, so this is dy dx is y prime divided by x prime, so that's sine of t squared divided by 5. Okay. So if I take the derivative of dy dx with respect to t, well, that'll just be 1/5 of cosine of t squared times 2t for the chain rule. But then I got to divide by dx dt. And that's where they're getting that 25 in the denominator. So I'm choosing answer choice C. Okay. Oh, A is very unfortunate, right? Because that A is if you just made that fraction arithmetic error, that would be really unfortunate. Just be careful there. All right, so moving back, number 17. Area volume, we love that. All right, maybe I'll draw you a picture of this. R is the region in the first quadrant bounded by the graph of y equals square root x minus 1. And the x-axis, and I got to scroll a little bit, the vertical line x equals 10. Which of the following integrals gives the volume around the y-axis? Okay, I need to draw a picture of this just to make sure. Square root of x minus 1. I feel like that would start here where x was 1, because if x was 0, I don't know where the graph would be. So it's going to look like that. The line x equals 10. Okay, so maybe that's here. We're going to rotate around the y-axis. Okay, so I'm going to need a large radius and a small radius. Okay. Large radius goes from the axis of rotation to the far edge of the region you're rotating. That's going to be my large radius A. A equals right minus left, 10 minus 0. And then small radius goes from the axis of rotation to the near edge of the region we're rotating. That's called B, and then B is going to be right minus left. Wait a second, I need an x equals this minus x equals that. Okay, this is y equals x minus 1 square rooted, so I just need to, maybe I'll square both sides. And solve for x. And then, okay, this is x equals y squared plus 1 minus x equals 0. So right minus left, right minus left. And then we know that volume is going to be equal to pi times the integral of a squared minus b squared. Since we're rotating around the y-axis, that would be dy. All right. Moreover, you see that a and b depends on y, so it's going to have to be a dy integral, meaning that we need like bounds of integration that are going to be y's. But at this point, 10 squared is 100. You've got it. It's answer choice D. But you can see that at 10, the square root of 9 is 3. Okay, that's why we're integrating from 0 to 3. I know that was a question that we had. Okay. Moving back again. Okay, 16, I'll do 16a and 16b. Now, the reason these were, some of these had 2 questions in one kind of Schoology item was because I thought I wasn't going to have enough time to get this ready before first period, and so I was clipping them 2 at a time when there were 2 on the same page, and then it turned out I had like 15 minutes left. I was panicked for nothing, but that is why I was giving you 2 questions on the same problem. All right, f has a continuous derivative. I guess that's good to know. F of 0 equals 1. F of 2 equals 5. Where are they going with this? Oh, I know where they're going with this. Integral from 0 to 2 of f is 7. We want to know about the integral from 0 to 2 of x f prime of x. Okay, this is integration by parts. And hopefully you remember this, because this is like one of the only ways I could reasonably ask you to do integration by parts in this year and have it be, calculator internet proof, was to just kind of give you this problem where it was x f prime of x. So I know that the integral of u dv equals u times v minus the integral of v du. And if this is an integral from 0 to 2, then that's going to be an integral from 0 to 2, and this is going to be something we need to evaluate between 0 and 2. So I'm going to let u equal x, because remember, dv needs to be something we know the antiderivative of. Now, I know the antiderivative of x, but I really know the antiderivative of f prime, and that's going to be the way to go. So hold on, let u equal x, so du is dx, and then we'll let dv be f prime of x dx, so that v is equal to f of x. Okay. And then u times v, so x, f of x, from 0 to 2, minus the integral from 0 to 2 of v du is f of x dx. But hey, look. Well, I thought I had, I'll just use orange. Hey, look, this, well, we already know what that is. That's 7, right? That's nice. I'm not looking for a highlighter. Really? Oh, there they all are. So this is 2 times f of 2 minus 0 times f of 0. So I'm not even going to put that in there. Well, maybe I'll say 0. Minus that orange box is 7. 2f of 2, so that's 10. Minus 7 is 3. That's answer choice A. All right. 16b. Which of these are conditionally convergent? All right, so I'm just copying the problem. All right, these 3 of these, which is conditionally convergent? That's the same question as asking if they weren't alternating, which ones would diverge? Okay. Which ones are only converging because of the alternating part? So I go over here. And so this would diverge by the p-series test, right? This is the power is 1/2 because it's the square root. And the power would need to be bigger than 1 in order to still converge, without the alternating part. Same over here. The power is 1, the highest power I see. So it's very similar to the harmonic series, which we, of course, know diverges. And what else was I going to say here? Oh, yeah. So this diverges and this diverges. This one would still converge. You could use the ratio test and show that it converged. That's one of those that, you did it a couple of months ago. You showed that this one converged absolutely. So this also converges absolutely. So it's going to be 2 and 3 only, which is answer choice C. All right, number 15. This one got a lot of y'all. And who knows, maybe you're sitting there, maybe you're just tuned in right here because, why is it marking me wrong? Is it an error? It's not an error. You've made a slight error. And that's okay. We're still just trying to get a little bit better at calculus each day. And part of that is making errors. So, number 15. What I want to do is I want to just work this one. I think if you got this one wrong and I just work it without talking about the graph at all, that you'll understand why you were wrong. So we want to know the value of the integral from 0 to 12 of f prime of x dx. It was 12, right? Mm-hmm. Yeah, okay. Okay, I can scroll this one. The image was just a little too large. So I anti-differentiate. I plug in the top and bottom and I subtract. Well, that means that's f of 12 minus f of 0. And you are looking at the graph of f, which means that you do not need to be counting areas or anything like that. You just figure out what f of 12 is, figure out what f of 0 is, subtract them, and then you'll get yourself an answer. The trick is the actual amount of area underneath the graph, the net signed area, is very close to the actual difference in the two functions, which is why it's got that lightning bolt shape, I guess. Anyway, I thought this was a pretty clever problem myself. So this was equal to -4 minus 4 is -8. Okay, so it's just an issue of like, hey, you're looking at the graph of f, not f prime. That was number 15. Number 14. All right, so you're approximating the integral from 0 to 4 of the square root of x. I think this is something, they didn't draw you a picture, so you're supposed to be like visualizing it. And maybe you can visualize this in your head, or maybe you should just draw a little picture of it, because we know what the graph looks like. Okay, a left Riemann sum, a right Riemann sum, and I would assume a trapezoid sum. Yep, and a trapezoidal sum, each with 4 subintervals of equal width is used. L is left, R is right, trapezoid sum. How does it work? Oh, that's very, very clever. Okay, what I do with these to figure out, like, you know, is it an overestimate and underestimate, how much, is don't use 4 subintervals. I know they told you you had to use 4 subintervals. Use 1 subinterval, and that will draw you a much clearer picture of what's going on here. I think I want to actually maybe try to make this a little more accurate, a little less circular. So I'm going to try that a second time. Yeah, like that. That's much more like it. What I'm going to do is I'm going to draw, let's say, a left Riemann sum. And maybe I'll just start from here and go to there so that you can see what I'm talking about. Left Riemann sum I will do in blue. And then the right Riemann sum, I guess I'm going to do in orange. And in green, whoops. Green, I will do the trapezoid approximation, which, as we know, is almost always the best. And then the true amount of the integral, well, this could be tough. Maybe I'll just kind of give it, oh, this is probably a bad idea, but I'm going to just give it pink stripes. The true value of the integral. So you can see that the left Riemann sum has the least amount of area. The trapezoid has the next. The true value of the integral has more area than the trapezoid, but less than the orange area. And the right Riemann sum is the greatest, which is, well, I think that's answer choice B. Yeah, that was a good question. I like that one a lot. I think this may be the first time I've used this set of problems in my class. I may not have used it in the past. I may have been saving it for just a situation like this. Okay, which of the following is the interval of convergence for the series? Okay. All right. I'm going to say that based on what I can see here, I'll copy down the series for you. X plus 4 to the n divided by n times 5 to the n plus 1. You can go and you can do the ratio test on this thing, and maybe that is what I will do. But I'll tell you, if you can just determine, based on the answer choices, that the interior of the interval is -9 to 1. Oh, wait. Hold on. we don't even need this. We don't need to check the endpoints, right? This is centered at -4, and it has a radius of 5. Okay, so that means it's going to 1 and going to -9. The only one that even has that like skeleton is answer choice A. So that will be enough. Now, if you are in a free response scenario or whatever, and you have to find it yourself, and you don't have answer choices suggested to you, what we're going to do is we're going to run the ratio test. I'm going to do that kind of just quickly because I don't want to waste a whole bunch of time, but also I'm going to do it because if you don't want to see this, you can just skip ahead to the next problem or skip to whichever problem you tuned in for in the first place. All right, we're going to do the ratio test, which involves the limit of the ratio of the coefficients, or the ratio of the absolute value of the ratio of the coefficients, whatever. Okay, so x plus 4, I'm going to plug in n plus 1 wherever I see n. N plus 1 would be n plus 2. I'm going to flip and multiply n, 5 to the n plus 1. What is that? X plus 4 to the n, and I'm absolute valuing it. Okay, so when I go in and do that, I'm going to lose all but one copy of the x plus 4, all but one of these 5s, and then I'll have an n over n plus 1. Very frequently, you will end up with an n over n plus 1. So that's the limit as n goes towards infinity of the absolute value. I like to collect all the things with n together. Makes it a little easier to compute this this limit over x plus 4 over 5. All right. As n goes to infinity, this fraction goes closer and closer to 1. Meanwhile, this thing just does not care, right? It does not care what happens to n. It's still going to be x plus 4 over 5. So the bigger n gets, the closer this thing is getting to 1, and in total, the closer this whole thing is getting to this x plus 4 divided by 5. And now with the ratio test, what we need is we need this absolute value to come back less than 1. And if the absolute value of a thing is less than 1, then that means that thing is definitely stuck between -1 and 1. And then you kind of just, do the usual thing. And we're going to have to check the endpoints, which can be a little tedious. And, usually the same thing happens every single time. One of them is going to be alternating harmonic, the other one's going to be harmonic. But these are the things we do, right? This is the price we might have to pay if we're hoping to get 2 units of calculus credit for free, or for the low price of $100. So at x equals -9, I just plug into the original series, which you can't see anymore, but it's right there. -9 plus 4 is -5 to the n over n times 5 to the n. Okay, this is becoming, well, -5 to the n is -1 times 5 taken to the n is -1 to the n, 5 to the n. I'm going to cancel off those 5 to the n's. I'll have a -1 to the n over n. This is the alternating harmonic series. You know what happens to the alternating harmonic series? It converges. So at x equals -9, this is a place where my series is converging. It's part of my interval of convergence. And then at x equals 1, what am I doing? Oh, I'm just going to plug in 1, and hopefully this goes a little better this time. Yeah, 1 plus 4 is 5 to the n. Whoops. I didn't realize that was a 5 to the n plus 1. What's going to happen here, I should address this. That's a 5 to the n plus 1. X plus 4 to the n. Okay. This is going to be an n times 5, which you could then factor out of the sum, and you'd be like 1/5. And 1/5 of something that's converging is definitely also going to converge. So at x equals 1, probably need to scoot that so my face doesn't start covering. At x equals 1, I'm going to have x plus 4 is 5 to the n over n, 5 to the n plus 1. Again, the 5, or almost all of the 5s will cancel. And I'll have 1 over 5n. which is the same as the sum of 1/5 of 1 over n. That's the harmonic series. The harmonic series diverges. Not going to be part of my interval. But you didn't need to do all this, right? There was only one answer choice that started at -9 and went to +1. I'm just saying, if you're weak on the ratio test, here's another example of me working it all the way through. Okay, so harmonic series dive. And these are appropriate rationales to give in the free response section. Like if this was a free response section, this would get full credit. Okay. All right, that was 13A. For multiple choice, please don't go through all of that business. It's just not necessary. It's not necessary at all. For 13B, polar slope of tangent line. Hopefully y'all are starting to notice that's a pattern on multiple choice, no calculator. It's been on both of them that I've given you so far. I'd say it's a safe bet to see on your exam this year. Because you're going to have to do some hand computation, which actually I think to us is a luxury because I think the digital exam is going to be just a whole world of unpleasantness. Questions about theorems and limits and which the following could be false. That's what I think is going to happen. Who knows, though. Slope of the line tangent to the polar curve r equals 3 theta. Well, the thing that you're supposed to know right here is that dy dx, that's the slope of the tangent line, that's equal to dy d theta divided by dx d theta, where x and y are r cosine theta and r sine of theta, respectively. So I like to do y first so that it's on top, so I don't make that classic mistake of doing x divided by y. Y is r sine theta. R is 3 theta, so that's 3 theta sine theta. Dy d theta is going to be equal to, I'm going to have to use product rule, it's not the end of the world, so that's 3 sine theta plus 3 theta. Leave 3 theta the same, take the derivative of sine, that's going to be cosine theta. All right, cool. And then I'm going to plug in, let's see, the point where theta is pi over 2. They're always pretty polite about that. Yeah, because cosine of pi over 2 is 0, I like this. 3 times the sine of pi over 2, that's 3 times 1. This looks nice. That's 3, okay? Is that going to be enough to determine? I mean, I think that pretty much means that it's got to be answer choice D. Because your options are negative pi over 2, negative 2 over pi, 0, and 3. So, like, you see what I'm saying here? I don't think maybe, who knows? Maybe it'll be 3 divided by 6 pi. Maybe I should just go ahead and do x and x prime. X is r cosine theta. This is one if you're running short on time and you see you got 3 and only one of the answer choices has anything kind of even related to 3, you might want to choose it and move on. X equals r cosine theta, dx d theta. Oh, whoops, I need to actually do that. All right, take the derivative of 3 theta, leave cosine the same. That's going to be negative sine of theta, so maybe I'll just make that a minus. Oh, what a tragedy. This thing's just completely empty. I guess I can't be making any more errors today. Yeah, good luck me. I usually have a bunch of these in my drawer, but you know, this is just not a very typical time in terms of my organization. Oh, I found one. It's not the good kind though, so I'm going to try to not make any more errors. Anyway, so 3 theta sine theta is going to be, actually, I do think it's going to be one of the negative 2 over pi or pi over 2. Sure enough, well, that's why you can't be making these rash decisions. You got to take it all the way. X prime of pi over 2, that's 0. Negative 3 pi over 2. Oh, I see how that could work, yeah. And so y prime divided by x prime will be 3 divided by negative 3 pi over 2. That'll happen. That'll kick back up to the top. Negative 2 divided by pi. That's answer choice B. Shows what I know. All right. Number 12. Which of the following? Okay, I was curious about this problem when I snipped it to put on the problem set today. I did not think all the way through. All right, so they're telling you that the integral from 1 to 4 of f is 8. And they're also telling you that the integral from 1 to 4 of g is -2. All right, which of the following are not going to be able to be determined from the information given? I haven't looked at the answer choices, but anything that involves x values that are not 1 to 4, we don't know, right? Well, that did not help me at all. That did not eliminate any of the possible answer choices. So, g of x from 4 to 1, yeah, that's going to be +2. The integral of 3f of x would be 3 times the integral of f, so that'd be 24. We know that. Okay, d, 3f plus g, we know how to split that off. We know about the linearity of the integral. It's c. We don't have just like a general product rule for integration. We have a product rule for when we know how to anti-differentiate one of the factors. And even then, sometimes integration by parts isn't 100% certain that it'll work. Okay, so that would be answer choice C. Yeah, we can't do f times g inside the integral. We just don't know. We don't know how to deal with that without more information about f and g themselves. Anyway, number 11. Was there a second? Number 12? That was the scrolling bar, the sideways scrolling bar. All right, number 11. I'll be honest. I was pretty let down by the first two sections' performance on this item because this is the type of thing that we just have to know. Okay, it's asking which of the following statements is true about the series sum from 1 to infinity, -1 to the n, times n, divided by n squared plus 1. So what am I supposed to look at this and think? First of all, 1 second. No, I'm going to have to go around. I haven't used one of these in a really long time, but I hope it still has some juice in it. First of all, that means it's alternating. Right, that's a big deal. Because if a series of constants is alternating and it's bigger on bottom, then we can show that it converges by the alternating series test, which is to say that it's alternating, the terms are getting smaller, and eventually they go towards 0. Okay, so that means that I'm looking for basically this thing converges by the alternating series test, because that's something I know. And you should also know, okay? Because that's not too bad. The alternating series test is really, you're supposed to know the 3 conditions, but if you know that it's alternating and bigger on bottom, then that's good enough. Okay, and so, yeah, I mean, the first two are going to be not true because the thing converges. And C is not true because, well, you can't compare it to 1 over n squared. Can't limit compare it because then you'd have still that you haven't dealt with that n, basically. It needs to be net bigger on bottom by 1. Okay, so that one was answer choice D. And, you know, we got to be better on that. We have to be better on our series rules. But we still have plenty of time to get there. All right, this next one was just had a cool looking graph. You know, it kind of looked like a crescent moon, kind of, but it also looked like a talon. This is number 10. This is the polar graph, right? But what they're saying is, maybe I'll give my best artist's rendition of. This is approximately what the thing looks pretty good to me. And then I think this was the origin. And that's all you need to know. And they said, well, all of the answer choices were G minus F in some sense. So I got to know that this one is G and that one is F. And so the thought is, when you are going from the origin to the edge of the region, and you are hitting both curves, that's where we have to subtract 2 integrals. Okay, and we know that the area that gives the integral is 1/2 r squared d theta. And, you know, we're going to take one and subtract the other. Which means that's why we need f squared, or g squared minus f squared, not g minus f total squared. And, you know, if you need more information on this, come talk to me or go back and look at all the stuff that we did when we talked about polar coordinates. Okay, and that was answer choice D again. There's a lot of D in this one, I think. So 9, also very commonly missed in my morning A-Day sections. But I'm actually okay with this because if we're going to miss problems at a high rate at this point, well, if you're just missing them because you haven't memorized all the stuff that you need to memorize yet, that's still in your control, right? That's something that you control, that on the day of the exam when you walk in, if you know your formulas or if you don't know your formulas, that is that's something that is up to you, you know? Because so many things right now are out of our control. We need to just grab hold and hold on tight to the things we can. Okay. So anyway, number 9. Which of these series converge? They're all alternating. I'm looking for one that's bigger on bottom, right? And so I'm going to say the one with the square root in the top and the n in the bottom. There's a 2. There's a -1 to the n, and there's a summation symbol. That's the one that I'm going to choose. The rest of them are not bigger on bottom. So, I mean, that's the divergence test, right? The quick divergence test is if the terms themselves don't go to 0, your series doesn't have a chance to converge. And, well, A, those terms are getting closer and closer to alternating between -1 and 1. That's not going to help. B, you're going to alternate back and forth between a half and -half. Those terms aren't going to 0. C, C's bigger on top. Those terms are getting bigger. So are you going to add, like 1 to 2 to 3 to 100 to 1,000,000 and have it converge? That's not possible, right? It's got to be bigger on bottom. We've got to be adding something that's pretty much 0 by the time we get to big values of n. All right, 8a. All right, another improper integral. I think it's good that we're practicing our improper integrals. I do remember us being very weak at that at the time when we went through it, but maybe not so bad this time. And we like improper integrals provided that they're in multiple choice, because then we don't have to be super careful about the way that we show our work, right? That's something that we do have to be careful about on free response. So what I will do is I will get to the point where here's where you would have to be careful. Here's what I'm going to just do if it's multiple choice. So integral from 1 to infinity of 6 over x plus 3 to the 3/2. I actually quite liked this integral. I thought it was a good one. What you're going to want to do is rewrite it as a power. Okay, I factored out the 6, but you could put the 6 right there if you wanted. And so what I'm going to do is I'm going to, actually maybe I will, because I'm not done anymore. This thing's got to go in the trash. Let's see. Hey, this one's pretty all right. Not as good as the other one, though. So I'll put that 6 there, and I'll bump up the power by 1. So -3/2 plus 1 is -1/2. Divide by the new power. Dividing by -1/2 is like multiplying by -2. And then I'm going to plug in top and bottom and subtract. All right. Now here's the point where we would have to be careful about our work shown. If we say we're in a multiple choice world like we are, and we don't care, and we're just really trying to work this fast as possible, I'm going to call that -12 over square root of x plus 3 from 1 to infinity, right? And I'm going to think about what would happen as x went to infinity. This is going to get really big. You take -12 and you divide it by a massive number. There's not going to be anything left. So that's 0 minus -12 over the square root of 4. That's going to be positive 6, which is answer choice C. Now, suppose this is a free response scenario, and we have to be very careful about the way that we're showing our work. What I'm going to do is actually from here, I'm going to say that this is, okay, I haven't actually heard a definitive, I think that this is okay, to not say that it's the limit of the integral from 1 to b, that we can anti-differentiate and take that up to, say, and then take the limit as b goes to infinity. Okay, and this is not just some sort of thing where, as readers for the AP exam, we're being needlessly picky. The definite integral is defined for is defined a to b, and for a function that's continuous, or at least piecewise continuous. To put an infinite discontinuity or an infinite bound of integration, that all of a sudden we don't have. That's not how our. It's not how our definite integral is defined. So this is like, in terms of like mathematical rigor, this is necessary. Okay. But in terms of actual problem solving, depending on where you're going with this is okay. In a multiple choice. If you want to get all the credit on free response, you better turn it into a limit. So this, I'll just rewrite this once more. So negative 12 over the square root of b plus 3 minus negative 12 over the square root of 4. And then we say that's equal to 6. Because that's 0 minus negative 12 over 2. Okay. For b, okay, this one, I'll show you how to do it the proper way, but I got a much better way. And something that I feel like has kind of gotten lost this year. That in previous years there was kind of a staple of AP Calculus, and that is taking the derivative of the answer choices, right? When you don't know what to do. This year, we've had so much available to us. We've had our friends, we've had our computer, we've had the internet, you've had pretty much constant access to me, and I have not said no when you've asked me how to do a problem. But occasionally, in the past, people had to, be on a test or on a quiz or something. I'm not going to help them. They got a multiple choice problem, and they don't know how to solve it. So sometimes you just have to take the derivative of the answer choices. So maybe you have, this is 8b, right? Yeah. 8b dy dx is 2 minus y. You might not immediately see this, but this is a separable differential equation. I can divide both sides by the 2 minus y, multiply both sides by dx, and then I can solve that. Okay. Now, before I go any farther than this, I want to say that you can eliminate choices C and D just based on the initial condition, right? I said this graph passes through the point 1, 1. So, I'm going to do this. You would think that the antiderivative is log of 2 minus y, but then you take the derivative and you realize, oh, there's going to be a negative consequence for the chain rule. So I'm just going to prepare for that by putting that negative there. And then I'll have x and plus my constant of integration, right? Now, having worked this problem once already, I like to kind of just solve for y and then worry about the c after the fact. And yeah, I'm going to do that because I think that since that's how I always have done it in the examples and the videos and everything, that's probably what you would do too. And that will leave you kind of a little confused as far as the answer choices go. But it'll be all right. Okay, absolute value 2 minus y equals. All right. Now, at this point, you're going to be good to go, right? If you know that it's down to a and b, and you see that negative x plus c there, like, it's got to be answer choice B, because it's the only one that's got a negative x in the exponent, right? But maybe you're in a free response setting, and you don't have that option to you. That's why I'm going to just show you how to do this. Usually, we would take this c and bring it into the front. So that's what I'm going to do, even though it's not going to help me. In fact, it's going to actively hurt me. But that's what I would think. That would be the first thing I would think to do. Okay. You look at the answer choices, and it's like, man, I see that 2, I see that e to the negative x kind of happening there, but what's that? Where's that 1 coming from, man? I don't know about this. And the idea is that, how much do I want to say? Yeah, you can just take the derivative of the answer choices and compare them to y and see that b works after, eliminating based on the initial condition. But if I'm going to try to solve for the initial condition, you're like, where does that 1 come from? It's going to be y is 1 is equal to 2 minus 1, right? C e to the negative 1. right? We're going to divide the negativity, multiply across, and you get c equals e. And then if we had this being, instead of a c, being an e to the 1, then we can use that like algebra property that they told you about back in the day to get that. Wait a minute. No, this is not a plus. This is a minus with certainty because of the initial condition. So I'm just going to rid my, whoops. I think that's, yes, it's just not the same quality of eraser. All right. And that's why it's answer choice B. Okay. These are kind of a marathon. Okay. Speaking of marathons, I got an Euler's method question coming up here. All right. I'm going to have a good attitude about it. X plus 2y. Because Euler's method, although it can be a little tedious, at least it's not like conceptually difficult, you know? So I can at least, you know, be positive about that. Initial condition, f of 0 equals 2. Okay. 2 steps, equal length, starting at 0, going to x equals negative 0.4. It's like, okay. That would make the first step negative 0.2. So I'm going to need 2 tangent lines. All right, for the first tangent line, I've got a point that is 0, 2. I've got a slope, which I get by using dy dx equals x plus 2y. So my equation is y minus 2 is equal to, that looks like 4 times x minus 0. I'm going to plug in to get an approximation. So y is about 2 plus 4 times, okay, the first step goes to x equals negative 0.2. 2 minus 0.8, that would be 120. Okay, so my new point is x equals negative 0.2, y is equal to 1.2. All right, 2 steps, 2 tangent lines. So x plus 2y, what's that going to be? 2.2. And my approximation, I'm really closing in on an answer here, and hopefully you aren't as detailed in your work here. You don't need to write all these words. Just, you know, if you know what you're doing. I certainly did not do this much writing when I was working this problem, because think about it, you only got 2 minutes per question. And although, you know, some of them were easy enough, or if we know our rules about convergent alternating series, we could have solved those 2 very quickly and spent that time on this. I haven't seen anything else that's been that bad on the hand computation. Okay, y approximately equal to 1.2 plus 2.2. I'm going to plug in negative 0.4 plus 0.2 is negative 0.2. Now, before I even go any farther, I just want to point out to you, like I always do when I'm working Euler's method, if you have 2 steps of equal size, this ends up being the step size. And so you just got to check and make sure, did I multiply by that same number both times? I did. So I feel like, well, my chances of making an error are less than they would be if I saw a different number here and there. Then it would be guaranteed that you made an error, right? So 1.2, all right, now think about this. Maybe you're not the best at arithmetic. I'm not either. 22 times 2 is 44. Right? And you just know it's got to be smaller than 2.2, and it's not going to be 0.0044 or 044 probably, right? Just a little bit smaller because we're multiplying by just 0.2. And then look at this. 1.2 minus 0.4 would be about 0.8. And there's only one answer choice that's even in the vicinity of 0.8. And you're going to choose that one and move on with your life. All right. Okay, here we go. No problem. Take care. I'll come talk to you in your room sometime soon.
Okay.
And number 6. Number 6 is UDU in disguise. Did y'all? You? Number 6? number 6a, did you get that it was UDU?
No.
Okay, honestly, I'm not entirely surprised. That one is very tricky. What I was going to say about this one. No, you just use U substitution on this one. Oh, yeah. Oh, okay, yeah. Yes, that's the mean value theorem. I was like, yeah, I'm not really sure how you would use the mean value theorem to solve that integral, but like, if you did solve it, let me know, because I'm always interested in new techniques. This one is tough, honestly, as UDU ones go. And I will admit that when I first looked at it, they asked me to do it for them in third period. I looked at it, I was like, ooh, am I going to have to do some algebra on this thing? It's kind of what I first thought. But then I looked and I saw that I had e to the x plus 1 over e to the x plus x. And just like I asked my people in third period, I would ask you in person or in the computer. Is it? Definitely, those are not supposed to be pluses, they're supposed to be minuses, which would cause me a huge problem with my answer choice. All right, what's the derivative of e to the x minus x? Oh, you know what the derivative of e to the x minus x is. It's e to the x minus 1. And when we see the derivative of something appearing somewhere else and they're connected with multiplication or division, it's going to be u du. So I'm going to do my u substitution over here. I'm going to let u equal e to the x minus x, so that du is e to the x minus 1 dx. And then when x is equal to 0, I've got u is equal to e to the 0 is 1 minus 0. And when x is pi, I just don't understand why they would use pi here. It's like, it's terrible, you know? E to the pi minus pi. Okay, that's what I don't like about it. And who knows, maybe it'll make you feel a little better about this problem if I put a little box around this. I know some physicists seem to like it when I do that. It's the exact same. I just put a box around it. Okay, and this has become the integral from 1 to e to the pi minus pi of 1 over u du, right? Because this is exactly what I have there. E to the x minus 1 dx, that's du. So I just have 1 du. And then I have that u in the denominator. And so then from here it's gotten quite easy, you know. We know how to do this. But it's like, well, why would I plug e to the pi minus pi into log of absolute value of u? This is crazy. But they've asked me to do it, so I can, right? All right, you got to know log of 1, that's 0. E to the pi, well, 2 to the 3 is definitely bigger than 3, right, or approximately. So it's going to be answer choice D, okay? And then for part B, I'm going to just flip this page rather than try to cram the work in. Okay, for this one, the table above gives selected values for the differentiable function f. That's going to be important because then that's what we need to invoke the mean value theorem, which hopefully that's what I'm going to do right here. And which of the following intervals, right, must there be a number c with f prime equals 2? So what we need is we need a closed interval that has average rate of change 2. That, because of the differentiability of the function, will guarantee us a value inside that interval where we have instantaneous rate of change 2. That's mean value theorem. Average rate of change equals instantaneous rate of change. And all in all, this is a very friendly way for them to ask you that question. So let's see. Can I spot one that is going to have slope of 2? I decreased. Okay, I see. Because they're going on and x is increasing each time, right? So I need f to also be increasing to have any chance of having a rate of change be positive 2.
Yeah, and because like all of them are by 4, you need to just find.
Oh, that is a great point. Thank you for that. I would not have noticed that. Notice here, that's good enough that I'm copying down all the information for the problem. Not all of it, but x starts at 0. That's really nice. Yes. Okay. Since each time the run is 4, yeah, right, plus 4, in order for the average rate of change on a given interval to be 2, I would need y to increase by 8 when x increased by 4. So you go and you wait and see. There it is, 8 to 12 was actually where that happened. So since I had this, I'll show you what I'm like. I could just see, thanks to one of the students in my room right now pointed it out, that like I needed to look for a place where it increased by 8. But why, right? It's rise over run. Now, since for each pair of these, it's always a run of 4, I needed to get that 8 over 4 equals 2. So it's going to be 8 to 12. Answer choice C. I'm going to move on. I think that was enough on that problem. But I really liked that. I've seen that problem before, but not that generous. All right, number 5. This one is kind of, honestly, this is the one that caught my eye for me to use this problem set in the first place. Because that was one of the things I did not put on that note sheet video that I recorded, but you definitely want. And that's the limit definition of continuity, which is the limit of f of x as x approaches c is equal to the value of f at x equals c. So limit of f, x approaches c equals f of c. There's the limit definition of the derivative. The limit of rise over run as run goes towards 0. And there's the limit definition of e, which I don't think is actually that important for you. Definitely not that important for your life. But for the AP exam, technically it's something I'm supposed to tell you about. But e is the limit of 1 plus 1 over n to the nth power as n goes to infinity. But don't worry about that. That's not what we're talking about right now. All right, number 5. The function is not differentiable at x equals 5. That should be pretty much what you're thinking of when you hear not differentiable. A sharp corner. Because in some way, this sharp corner is like the minimally not differentiable one. You could also think of this, the vertical tangent, like y equals x to the 1/3 power, or even just a regular old-fashioned discontinuity. But you're not guaranteed a discontinuity when you have a lack of differentiability. So it's like these are the ones that are like minimally not differentiable. Okay? This is a must be true. A must be true because I just drew 2 of them. We weren't differentiable, but they were still continuous. B, limit doesn't exist. Well, this limit pretty clearly exists. Both of them do, right? C is the one that's true. The limit of rise over run, limit as x approaches 5 of f of x minus f of 5 divided by x minus 5. The thing about this is the limit of rise over run as run goes towards 0. This is equal to f prime of 5, provided that this limit exists. And moreover, if this limit fails to exist, then we say that this doesn't exist, and that's what it means to not be differentiable in the first place. So, the second derivative of a function f is given by, I really like this one. These are the good AP calculus problems, in my opinion at least. So they're saying that f double prime of x is equal to x times x minus 3 to the 5 times x minus 10 to the 2. Oh, wait. Oh. I thought this was going to be f prime was this, and it was going to ask how many points of inflection or something, but that's all right. Where is there a point of inflection? So you may be, especially if you took Calculus AB last year, you may be prone to wanting to make a table, or a sign chart. I don't like sign charts so much. I find them to be really just too much arithmetic for me and just kind of boring, and I like to draw graphs. So I can tell that this is going to be a 5th, 7th, 8th degree polynomial with a positive leading coefficient, which means that in some world, in some sense, this is what the outside of it looks like. Then I've got zeros at 0, 3, and 10. I know, it's not really drawn to scale, but that's all right. Because it's going to, this is a single root here, so it's going to pass through confidently. I forgot his number, but the guy who coined that term, I had not ever said that it was a 0 with confidence, but he was honestly one of the best students I ever had in my class. He was in Algebra 2. Yeah, I think he was also in my pre-cal, my calculus. He was also in my Algebra 1, but he was one of those repeat customers. But Really enjoyed having you in my class repeatedly, Shrinikit. So at 3, there's like a, what's it called?
I refer to it as
A slide. Hesitation, yeah. And that's why, and I think that was what we were saying, was that it was hesitant. And then he said, to contrast with the hesitancy of that one, he said that at a single root, it passed through confidently. And I was like, oh, yeah, I like that. I've used that every year since, or every time it's come up. And then at 10, it's going to bounce because of the even root. So any place, though, this is the second derivative. And any place where there's a sign change in the second derivative definitely coincides with the point of inflection on the graph of the original. So here and there are going to be points of inflection. Okay, and you don't have to draw a graph. If you just like think about it and like, oh, wait, odd power means it's going to just pass through, then I'm going to have a point of inflection. And that's what you do. All right. 4. Okay. With 4, you need to know, or 4a, you need to know that cosine x is 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial, and so on. But it turns out if you just manipulate the first 2 terms, you can solve this one, because none of them have the same first 2 terms. They all have a different first 2 terms. So cosine x squared is going to be 1 minus x squared. Squared is x to the 4 over 2 factorial. And then x times the cosine of x squared is, I'm just going to multiply both of these by x. And that's, right, that's just answer choice A. Yeah, cool. 4b is a L'Hopital rule limit. And I'll be real honest with you, if you're just watching and you just tuned in or something, I'm going to be kind of working through the rest of these really fast because I only have 8 minutes and it's Friday and I'm trying to get out of here right when I'm done working. So limit as x goes to, oh, that's nice. I like infinity limits. 10 minus 6x squared over 5 plus 3e to the x. I love this one, right? We know that exponential is more powerful than any power of polynomial. Even if this was 6x to the 99, or 999, or 9 million, that limit is still 0, because it's bigger on bottom. Okay, so I'm just going to say that's 0 and just kind of move on. Number 3. The sum from 1 to infinity of, I'm going to rewrite this as e divided by pi to the nth power. This is geometric, right? E divided by pi is a number that's between -1 and 1. So this is going to converge. And the sum will be the first term times 1 over 1 minus the common ratio. Well, the common ratio is going to be e over pi. And if you had wondered, dude, why don't you tell us the formula like every other person out there and say first term over 1 minus r? I'll show you. This is exactly why. Okay. Every textbook is always talking about a0 divided by 1 minus r. But it's going to cause arithmetic issues when your first term is a fraction. Okay. You plug in n equals 1, you get first term is e divided by pi. And what we can do is we can just directly multiply, right? And this is e divided by pi times 1 is pi. Pi times e over pi is, well, that's just going to be e. Isn't that so much nicer? That's answer choice B, okay? All right, I'll do this one, 3b down here. All right. H equals f prime divided by g. That's weird. All right, so remember that the quotient rule, it's bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So this is going to be g is -2, f double prime is 3, minus f prime g prime is going to be -3 times 5 is -15, divided by g squared is going to be 4. So I've got 9/4. Yes, that's answer choice A. I hope that was right. I really rushed through that one. All right, number 2. All right, I got 6 minutes. I think I can do this. I gotta hope. The derivative with respect to x of 2 sine square root of x squared. Interesting. This is a pretty serious chain rule question. All right. what I'm going to do, I'm going to start with the outside. So that's power rule. So that's 4 times that thing to the first times the derivative of that thing. And then the derivative of sine of anything is going to be cosine of that thing times maybe the derivative of that thing. Leave the inside the same. Derivative of square root of x is 1/2 x to the negative 1/2. So that 4 and that half is 2. Sine square root x, cosine square root x, that's divided by square root x. That's answer choice D. All right. 2b is the position is what was it? Log of t squared plus 1 and e to the 3 minus t. What is the velocity vector, right? Okay, cool. I scrolled. V of 1. Okay, well, v of t is equal to derivative of log is 1 over times the derivative of the inside is 2t, and then negative e to the 3 minus t, negative for the chain rule right there. Then v of 1 equals 1 over 2 times 2 is going to be 1, and then negative e to the 2. That's answer choice B. All right, I got 2 more. A is a really nice integral. Yeah, no, yeah, exactly. 4 minutes to do 2 problems. I should be able to do this. And there's 3 minutes, and I'm supposed to be the teacher, right? So I should be able to do this, right? 4x to the third minus x dx. I've done a lot of talking here. No, 2 to the 4 is not 8. That's what they want you to think. 2 to the 4 is 16. 16 minus half of 4 is 2, minus 1 minus a half is a half. That's 13 and a half. That's A. Okay, 1B. Which of the following is their local minimum? Oh, this is a good old-fashioned question here, right? So x to the third minus 3x squared minus 9x plus 11. F prime is 3x squared minus 6x minus 9. It's just 3 times x squared minus 2x minus 3. That is 3 times x minus 3 times x plus 1. I'm going to draw a little picture of this. This has zeros at -1 and at 3. It's a second-degree polynomial with a positive leading coefficient, meaning it looks like this. I hear the doors opening and closing. It must mean the time is rapidly approaching. People are getting let off early. Unfortunately, my students are rarely so lucky. It wants a local minimum, so that's where the derivative goes from negative to positive. That's right here. That's x equals 3. That's answer choice A. That's all for this video. Thanks for watching. If you found that this helped you understand any of the problems and you're still watching, I'm going to ask you to consider maybe giving this video a like.